Hello guys, a very happy morning to everyone of you. Guys, today we are just going to see about the thermodynamics previous year problem. So especially in this chapter, it means in this entire video, we will be covering lot of problems in thermodynamics. So it means properties of pure substance. So especially we are going to see the gate point of view as well as the XC point of view, chemical engineering point of view and production engineering. So related to thermodynamics, okay. So I think so you can understand. So it means I think so you would have already known about the basics of this property of four sections. Suppose if we haven't known any kind of thing, it means no, don't worry, because while we are just seeing the problems, we will have a clear cut understanding. Okay. So okay. So let us see the problems. So you can see this one. So it has been asked in GATE 2021 in mechanical engineering. Okay. So you can see the vicinity of triple point. Okay, they are asking the vicinity and the triple point. They are asking liquid boundary layer P. It means the pressure and temperature phase diagram for ammonia. Okay, it was given ln P equal to this entire thing. And similarly, solid vapor boundary. Okay, then the temperature of triple point of water is so pressure temperature. Okay, how the pressure and temperature will be? This is okay. This is like so. This is the pressure curve, and you can see this pressure curve. Wait. No. This is not a pressure and temperature curve, because you can see this is entirely pressure, and you can see this is pressure and temperature curve like this it will be. Okay, and you can see here what is the temperature and entropy curve. Okay, so this what we have just showed is this is temperature and entropy curve. So okay, the pressure and temperature curve, this you can see pressure and temperature curve will be like this. Okay, single point. Okay, you can see critical point. So here the entire thing will be, it means here subcooled region and here saturated, it means this is saturated curve. Subcooled region, here it means this entire stream is superheated vapor. Okay, so you can see here in this entire thing, it means the liquid and vapor phase will be represented a line point. Okay, suppose you can see this is subcooled, means this, for example this is subcooled, this is superheated. You can see this is liquid, this is vapor. So this is a phase transition. Okay, this is a means here the specific volume will be, but you can see here there is no specific volume. We don't consider. Okay, we just consider only pressure and curve. Okay, so you can see pressure represent this one, saturated, everything. Okay, I think so you can understand. So you can see pressure and temperature phase diagram they have just given. Okay, so next is solid vapor boundary. Okay, solid, so one side it will be, it means the thing will be. Okay, so the temperature of triple point they are asking. Okay, so let us go for triple point. Okay, how would generally the triple point will be? So you can see the triple point will exist like this. Okay, the entire thing. Okay, I think so you can understand. So you can see for general substance the triple point will be like this, but for water it will be like this. Okay, for example, how to say means so you can see triple point of means general substance will be like this and like this, like this. Okay, here it is a solid and here liquid and here vapor. Okay, so but triple point of water will be like this. You can see it is negative, it expands during the solidification, solid, liquid, vapor. Okay, so you can see this is fusion to melting, this one solid to vapor directly sublimation, and vapor to solid sublimation, and so you are okay. So this is pressure and this is temperature, pressure and temperature. Okay, I think so you can understand. So this is, you can see guys, in this thing it means pressure and temperature curve. It means you can see liquid as well as vapor. So you can see liquid and vapor. So I just this thing, it means this entire liquid and vapor only I just represent a line. Okay, I think so you can understand. So so you can see this is pressure and temperature. Okay, pressure and temperature diagram for liquid ammonia, I think so you would have known. Okay, so in this they have just given ln P, it means ln of pressure equal to this entire thing. Okay, okay, in the vicinity of triple point, here there is a triple point. Okay, so similarly solid, you can see solid to vapor, the boundary, it means solid vapor, this boundary is given by this one. Okay, I think so you can understand this. So the entire thing represents a triple point, so just equate. Okay, so simple thing. So ln is 24.38 minus 3063 divided by temperature equal to so 27.92 minus 3754 divided by T. So okay, now we calculate and find the temperature. That's it, simple thing. Okay, no need to confuse, no need to just go out of the scope. Okay, just use common sense. Just with the diagram the problem has been completed. Now you can just go for the second question. Wait, this note is not convenient in my point of view. I'll just take a note. No, wait, this is better. I'll take this one. Okay, let us see the second question. Okay, so what is the second question? You can see a rigid volume. Okay, rigid tank. Okay, tank volume equal to 550 meter cube, contains pure substance, saturated liquid vapor mixture. So saturated liquid vapor. Okay, so pressure is 400 kilopascal. So total mass of vapor is, okay, total mass, it means total mass mass of mixture equal to 20% means 0.20 mass of vapor plus 0.80 mass of vapor. Okay, I think so they have just given in this phase. Okay, so in this phase I think. Okay, so this thing, it means so it has been mass of vapor, mass of liquid is so much lesser, and here mass of vapor is so much higher. Okay, properties, temperature, saturation region, everything given. So they are asking the total mass of liquid vapor. They are asking the, okay, total mass of, it means mixture. Okay, interesting question. Okay, so I think so you got the point. So they have just given rigid volume. Okay, it means this entire volume. Okay, volume they have just given. Okay, how we can calculate the mass? So density equal to mass by volume. Okay, so we know the volume until 50 meter cube. Okay, so if mass of mixture equal to density of mixture plus into volume of mixture. Okay, volume is I think so around 50 meter cube. So how we can calculate this one? Okay, so density is 1 by specific volume. Okay, so it means so mass of mixture equal to volume of mixture divided by specific volume of mixture. Okay, so specific volume, it means the specific volume, how we can, the Fg equal to so definitely V E of Fg, so V of F plus of X of E of Fg. So I'm just to show you the guidance formula. See, it's often required to recheck and revise the formula once again. See, even I do just forget. Okay, so that's the most problem thing in the entire chapters. Okay, so you can see X is how we can just represent. X equal to mass of vapor divided by mass of liquid plus mass of vapor. Okay, this is represented X. Okay, this is one formula, and as well as the second formula will be so we can see specific volume equal to specific volume of the entire mixture equal to H, it means specific volume of fluid, it means plus X of specific volume of Fg. Okay, so these two formulas we need. Okay, so what is the mass of vapor? Mass of vapor is 0.80 divided by 0.80 plus 0.20 is 1. Okay, so X equal to 0.80. Okay, so V of F is, you can specific volume of saturated fluid is equal to 0.001084 plus 0.80 into V of F. Okay, it means vapor minus, it means Vg minus of Vf. Okay, so this is 0.46242 minus of 0.001084. Okay, calculate V of mixture. After calculating, put here, it means mass of vapor equal to 50 meter cube divided by this entire answer. Okay, suppose let us answer name sets y divided by y. Okay, we'll get the correct answer. Okay, that's it. So easy question, you can say just common sense. Okay, you can see this one. Okay, so you can just go for the next question. So it has been asked in GATE 2021 in XC. Okay, 4 different entropy and temperature diagram is written liquid to vapor phase. Okay, vapor phase is under constant pressure. Okay, represent which is correct one. So what is the required thing? So temperature, entropy. Okay, so generally it will be like this, and okay, this is the basic thing. So okay, so you can see here it is been given in a different format. Okay, so they have just given temperature in this side in the longitudinal axis, and it means horizontal axis, and entropy in a vertical axis. Okay, so how we can just write? Okay, so you can see here temperature is there and here entropy is there. Okay, so like this, like this, like this. Okay, am I writing correct? Maybe so here entropy increases, entropy increases. Okay, temperature particularly here you can see temperature increases. Oh, simple logic. Okay, so you can see here temperature increases. Okay, constant decreases, but you can see here temperature decreases. Okay, and constant and temperature again decreases. So temperature increases, so we just found another. So entropy, temperature, so temperature must be increased, constant and increase. Okay, so answer is here. Okay, this, so D is answer. Okay, wow, good question. It has been asked in GATE 2021 in XC. Okay, a rigid tank contains 1 kg of pure water. Okay, so rigid tank contains m equal to 1 kg, and liquid and vapor phase equilibrium at 10 bar. Okay, pure water, liquid and vapor phase. Okay, at 10 bar. So this is the other diagram. 10 bar. Okay, liquid and vapor phase. Okay, if the liquid and the vapor each occupies half of the volume of the tank. Okay, so then what is the thing? Mass of vapor, mass of liquid. Okay, so the net enthalpy of the content. Okay, the net enthalpy, so h of mixture. Okay, so h of liquid plus x of h of fluid with respect to gas. Okay, everything is given. Okay, how we can calculate the x? Okay, so you can see liquid and vapor consists of half of the volume. Okay, so you can see half of the volume means, suppose generally 1 kg means how much? Just think, guys, just think, basic thing only, we are just confusing in ourselves. Okay, so my question is, you can see if 1 meter cube holds so if 1 kg means, you can see if 1 kg means 1 liter make goes. Okay, so it means we need to calculate first x. Okay, after calculating x we need to just go and put here. Okay, and we can calculate this remaining thing. So but the basic thing is how we can calculate the mass of vapor and mass of liquid. Okay, so they just told it means this holds only half, this holds only half. Okay, so V equal to volume of liquid plus x of volume of fluid and gas. Okay, so this is the volume of mixture. Okay, so even though for that you can see by this also we can calculate f. Okay, if this is fluid, again you can see v of f and v of g is given, so based upon this we can calculate the x. Okay, but my question is how we can calculate the volume of the entire thing. Okay, suppose I think so, maybe in best case scenario volume equal to 1 meter cube, I think so. So because 0.50, this one 1.5 means this one 1 0, we can just calculate. Okay, let us see whether our assumption is right or wrong. mass equal to poured suck. Guys, literally, yes, we made a good mistake. A good lesson was learned by us. Okay, so what the thing is, you can see what is the thing, density equal to mass by volume. Okay, the same thing, just reverse it. Okay, so just go with the specific volume. So 1 by specific volume equal to mass by volume. Okay, so you can see mass equal to total volume divided by specific volume. Okay, so x equal to mass of vapor divided by mass of vapor plus of mass of liquid. So total volume divided by specific volume of mixture by specific volume of the entire thing. Okay, specific volume of vapor divided by, it means total volume divided by specific volume of liquid plus total volume divided by specific volume of vapor. Wow. So by this you can see we can calculate, we can neglect the entire V term. So 1 by V, it means specific volume of vapor divided by 1 by specific volume of liquid plus 1 by specific volume of vapor. Okay, so just make sure 1 by specific volume of liquid into V of vapor into V of liquid divided by V of vapor into plus V of liquid. Okay, so this one so V of liquid divided by V of vapor plus V of liquid, so it's entire specific volume. Okay, x equal to, so you can see here each and everything is given. Calculate the x value. Okay, after calculate h equal to h of f plus x of h of g minus of h of l. Okay, wow, such a good question, guys. Literally, see, basic thing only this one, so just use common sense. I'll just tell you this one again. Where is that one? It's okay. You can see x is mass of vapor plus x equal to mass of vapor plus mass of liquid plus mass of vapor. Okay. So you can see volume total equal to volume liquid plus volume of vapor. Okay, so it means you can see mass of it means mass of mixture plus specific volume of mixture. Okay, like this we just calculated, and you can see like this we just written. Okay, mass of liquid plus mass of vapor, this entire thing. So while we are just dividing, each and everything will come. Okay, specific volume equal to specific volume of fluid plus x of specific volume is. Okay, but for density you should not write like this. Okay, this is so much important. Only for the internal energy, enthalpy and entropy and the specific volume only we need to write like this. Okay, do not confuse about that one. Okay, so we can just go for next question. A closed system consists of it has been asked in gate 2020 next. Okay, using different liquid water and ethanol in equilibrium with its vapor. Okay, so what is the rule, Gibbs place rule? F plus P equal to C plus 2. Okay, F plus P equal to C plus 2. Okay, so what they have just given, liquid water and liquid ethanol, liquid water and plus liquid ethanol. Okay, both are in equilibrium, so phase number of phases only one, it means liquid phase. Okay, so the degree of freedom F, so compound you can see two compound. Okay, liquid water and ethanol, so F equal to F plus 1 equal to 4. Okay, 3. Liquid water and ethanol in equilibrium with its vapor. Oh, then phase result 2. Okay, oh, then 2. Okay, then definitely 2 will come. Okay, you can see, guys, liquid water and ethanol in equilibrium with its vapor. Okay, so there is also a vapor mixture. Okay, so I'll just explain to you. You can see this one. Where is that one? So you can see, I think so got the point. So here phase results 2. Okay, not only one. You can see liquid water. Okay, one is liquid water, so one compound, ethanol and ethanol in equilibrium and with its vapor phase. Okay, there is vapor also being present here. Okay, just a simple thing. Okay, suppose you can see if this is a phase diagram, so in this phase they are asking. Okay, see here there will be liquid water also will be plus of vapor phase also will be in this lake. Okay, good question. Okay, we can just see this one. So two identical pressure cooker A and B have total internal capacity of 6 liters. 6 liters. Okay, cooker A is filled with 2 liters of liquid water. Okay, cooker B is 4 liters of liquid water. Okay, 100. The remaining space is saturated water. Okay, if G represents the Gibbs phase energy and saturated liquid, which one will be the expansion correct? Okay, it's a good question but also a tricky question. Okay, so just think what might be the answer. Here mass of liquid is lesser, mass of liquid is how much higher, vapor, and here is vapor. Okay, they asked about Gibbs free energy. So see, temperature is same and the temperature is same. Okay, the main thing is this one. Okay, identical pressure over. Okay, so both boils in the same temperature, but mass of liquid is lesser. Here mass of liquid is, that's it. Okay, maybe in my point of view, since the temperature is same, I think so. Maybe both will be same. I think so. It means Gibbs will be same. I think so. It's my assumption only, but even I'm not 100% correct of it. Okay. They just given, okay, but how? So the thing is, first we want to see the Gibbs free energy. Okay, so you can see here the entire thing is, you can see Gibbs free energy. You can see, and I think so we would have a proper explanation, but okay. So you can see Gibbs free energy is totally dependent on enthalpy and temperature and as well as the entropy. Okay, so oh wow, so I think so guys, see such a basic thing only you can see about this one. So Gibbs free energy is what? Enthalpy. So Gibbs free energy equal to enthalpy minus of this one. Okay, so you can see temperature is 110 degrees Celsius. So I'll write two equals also. Temperature is how much? 110. This is temperature, entropy. This is temperature, entropy. Okay, 110 degrees Celsius. Okay, you can see here liquid will be, vapor will be, liquid will be, vapor will be. You can say Gibbs free equal to enthalpy minus temperature and as well as entropy. So you can see here guys, here each and everything is same. Okay, it means here you can see in this thing, if mass is given, any mass dependent is given here, no. Okay, so here it is, since it is independent of mass, so that's why the, it means D will be the right answer. Okay, wow. You can see this one, D means, you can see enthalpy of entropy of vapor of gas. Okay, entropy, sorry, Gibbs energy vapor of A equal to Gibbs energy liquid of B. Okay, it's okay, we can just go for this one. The liquid phase of pure substance is termed dash if the temperature is lower than the, so temperature is less, so there will be subcooled liquid. Okay, that's it. So about this one, you can just see a closed vessel contains pure water in thermal equilibrium with this vapor 25 degrees Celsius. Okay, this is 25 degrees Celsius. Okay, so the vessel is in this stage is kept inside the isothermal flask. Okay, this is isothermal. Okay, then here the temperature will be constant. Okay, and having maintained, so the heat, the vessel exchanges heat with the open, so it is, this one is not insulated. Okay, this will exchange heat. Okay, if the valve A is now open inside the oven, what will happen? Wait, I'll just, a container vessel pure container under thermal equilibrium with its vapor. Okay, so you can see this 1 atm, it means in the ambient air at 1, see they haven't a close vessel contains pure water in thermal equilibrium with its vapor, and so then inside will be 25 degrees Celsius, okay. Okay, the vessel exchanges heat with the open atmosphere, okay, and attains a new thermal equilibrium at stage 2, okay. Now it has been attained a thermal equilibrium, okay. Then now inside also 80 degrees Celsius, outside also 80 degrees Celsius, okay. So what might be the temperature, okay. So all VA is open from inside, so what will happen after opening? Water vapor inside the vessel will come out, so hot air will go inside the vessel through the all the vapor inside will immediately condense now. What might be the answer, guys? Since it's literally it's now quite confusing. You can see inside also 80 degrees Celsius, outside also 80 degrees Celsius, okay. So inside is 1 atmospheric pressure, but outside they have been given what is the atmospheric pressure, okay. Since temperature is same, so temperature same, so delta T is constant. So just assumption we can just put, since delta T is constant means PV equal to P1 V1 equal to P2 of V2, okay. So P1 is 1 atm and volume this one, so V2 volume is a little bit quite bigger, I think so. So P1, let us say 1 into 1 divided by, so V2 will go downwards. V2 is quite high, I think so. So 2, let us say P2. So it is 1 into 1, it goes P2 will be lesser, okay. So okay, B is hot air will go inside through the volume. So I just thought A will be the answer, okay. Let us see. B, just over there கொடுத்து முடிச்சிட்டாங்களே. Guys, just a basic sense, right? Sometimes basic questions we are just not able to solve, okay. So you can see it is water vapor, not superheated vapor, okay. Basic questions also, see, that's why literally it makes me anger. So water vapor, okay, this is water, okay. You can see they haven't just mentioned it is subcooled liquid or any kind of thing. Water vapor, okay. You just think just placing 1 glass of water and we are just sealing it and we are just making, okay. You can see this entire thing is the water and this is vapor, just a vapor, not superheated vapor, okay. This entire thing is 25 degrees Celsius, okay. So now we just place into 80 degrees Celsius means you can see, so if 100 degrees Celsius and you can see if 100 degrees Celsius only, it means at 1 atm only it will become saturated condition, okay. So since it is been sealed, okay, definitely for saturated to attain it needs so much it means how to say, means the pressure will be lesser inside, okay. I think so, you got the point. So you can see only 80 degrees Celsius that. So since it is completely sealed, okay, the pressure inside they haven't just given. So only the, it means ambient is 25 degrees Celsius, here ambient is 80 degrees Celsius. So the temperature increases, okay. And you can see the pressure also increases definitely. So it means like this is there, means if it means this is 100 degrees Celsius and you can see this is, okay. So at the time, at the beginning you can see only 25 degrees Celsius temperature and pressure, okay, some pressure and entropy, you can see 25 degrees Celsius, okay, here 80 degrees Celsius. So to attain 100 degrees Celsius and only 1 atm, okay. I think so, got the point. So still now the pressure is not so much higher, okay. I think so, got the point. Suppose if pressure and temperature means you can see this one. So this one will be 1 bar 1 atm and this one will be 100 degrees Celsius. But now where it is been there, it is 80 degrees Celsius. You can see the pressure will be lesser. So inside the pressure will be lesser, outside the pressure is, you can see 1 atm. So from outside to inside only the air will come. So I think so, got the point. That's a basic question, guys. So you can just go for this one. I think so, can answer. Okay. So you can just go for this question. L1, L2, L3 are latent heat of vaporization at critical temperature of nitrogen. So critical temperature, okay, so definitely all will same D. So can just go for next question. You can see this one. So they have asked in chemical engineering in 2019. Consider a vessel steam contains steam, okay, vessel, okay, contains steam, temperature is 180 degrees Celsius, okay. The initial steam quality, so initial volume of vessel, initial volume of V of vessel is 1 meter cube. Initial volume, okay, they haven't just given any other thing. Initial volume of initial steam quality is given. Initial steam quality, it means mass of vapor or liquid of water, they haven't just given, okay, maybe x equal to 0.5. so the vessel losses heat at constant under isobaric, okay, pressure is constant, okay, so heat is lost, Q is lost, okay. So definitely mass of vapor will convert to mass of liquid, okay. So you can see the quality of steam reduces to 0.1. So x is at the beginning 0.5, now it is being reduced to 0.1, okay. So at 10 hours duration, okay, for 180 degrees Celsius, okay. So just draw the curve diagram. So saturated curve, and you can see temperature is this is pressure constant, okay. This is pressure, so pressure constant, okay. So enthalpy, entropy, everything is given. They are asking the Q. Literally one of the good question in my point of view. So whenever we just go with respect to thermodynamics first law, what is the thermodynamics first law? Q equal to W plus of delta U, okay. But here you can see, here W won't become, okay. So Q equal to delta U, okay. So delta U can be written as U is H plus of P of V, okay. So maybe this format also we can write, or in enthalpy format also we can just write, okay. So Q dot, you can see Q dot, okay, it has been given with respect to hour, okay, then 10, okay. So dq of dt, okay. So then definitely each and everything will be represented in a dt format, okay. So in my point of view, h equal to h of fluid plus x of h of fluid of g, and this pressure is constant, okay. So v equal to v of fluid plus x of h of v. But yes, I think so, guys. Literally we want to manage, it means change of enthalpy is h2 minus of h1 plus p v2 minus of v1. Oh, you can see this one, it means for this entire thing, x is, it means one case in x equal to 0.5, another case x equal to 0.1, okay. First calculate h, it means h2 equal to how much, and calculate h1. So later you just subtract each and everything. So second thing, x equal to 0.5, x equal to 1. So calculate v of 0.5 and v of 1, and minus v2 minus of v1. So go and put here, and pressure is how much. Isobaric condition, okay. Oh, the pressure that they haven't just given, okay. So then change of entropy will be, it means u equal to u of f plus x of u of f of g, okay. First put 0.5 and next one put x equal to 0.1 and calculate this one, and q dot will be there, okay. Let us see. So divided by hour they have just given, okay, then we have to just multiply the 10 hours. See, I just told you, divided by 10 hours, okay. heat loss equal to change in enthalpy. Okay, yes, definitely. Guys, literally in my point of view it's such an amazing question. Okay, see, let us try about this way. Okay, so yeah, if we tried in this way, what will be the answer will come. So let us give a try. See, because since we don't know the pressure is also so much important. Okay, so P equal to m or T. Okay, since it is being pressure, so you can see R of steam we don't know. Okay, so mass of steam, R of steam also we don't know. Only we know x 0.2, so that's why it is so much difficult to calculate. Okay, so let us try. V of f is okay. U2 equal to V of f is 762 plus x is 0.5, first one, and then 2583.7 minus of 762.08 into 0.5, this one plus 762.08, this one is U2 is 1672.89, U1 is 2583.7 minus of 762.08 into 0.1, that is plus 762.08, this one. Okay, so 944242. Okay, this thing. Okay, just minus 1672.89, this one. So 728.62. Okay, so divided by 10, 72. Okay, let us see. Okay, guys. Yes, we made a good mistake. Okay, so what's the mistake we have just made is, it means how to say, we because yes, it means Q equal to, it means what, delta U. Okay, each and everything is divided by mass. Okay, so now here also we need to just divide the entire thing with respect to mass. So we literally don't know what is the mass value. Okay, so first we need to calculate the mass value. Okay, so Q dot, it means divided by mass. So mass will just go here, means it is, this entire thing is specific internal energy. Okay, so if specific internal energy also we need to show multiply. Okay, so first we need to also calculate the mass. Okay, see, my point of view literally is one of the good means difficult question. Okay, but we can just learn a lot of other things, but in this way what they have just given also some of the interesting thing. So you can see it is constant pressure, so constant pressure Q equal to enthalpy change H2 minus of H1. So I think so you would have known in the heat interaction. Okay, so heat loss equal to change in enthalpy H1 minus of H2, anything. Okay, so later on while you just calculating H1 minus of H2, is entire thing will come, H1 minus of H2 is this one. Okay, this entire thing. Okay, so the next thing is, you can see what is the volume. So volume equal to mass upon, so density equal to mass by volume. Okay, so okay, mass equal to volume divided by specific volume. Okay, so okay, so volume divided by specific volume. Okay, so specific volume, what you can just write So mass of mixture is specific volume of gas and fluid. Okay, just go to the basic. Guys, anyways, I'll just explain you from the first. So that's that question. Okay, so from the first I'll just explain. So vessel, okay, 180 everything is given. So x equal to first is 0.5, x1 x2 is 0.2 1. Okay, you can see since it is isobaric process, q equal to delta h. Okay, so maybe this one, so final, so this one is the initial, so h1 minus of h2. Okay, so since it has been last, so you can write in your format. Okay, minus will come. Okay, so just however you calculate, the answer will be same whether you put h2 minus of h1 or h1 minus of h2 is same. Okay, so h1 is what is h of fluid plus x of h of gas minus of h of f. Okay, this one is minus h of fluid plus x of h of gas minus of h of f. Okay, so this entire thing just calculate. Okay, entire thing we need to calculate. It means x equal to 0.5 and this one x equal to 0.1. Okay, while you are calculating, we will get a certain amount of value. Okay, certain amount of value. Okay, so we will get how much? You can see this one. We will get 805.996 kilojoule per kg. Okay, this one, and then the heat loss will be, it means q will be, our answer will come in kilojoule per kg. We don't need kg, so we want to multiply certain amount of mass here. So you can see this they have written in a different format. Okay, h of f plus of x of, it means this one just multiply x of g minus of x of h of g. Okay, so you can see it means h of f minus x of h of f plus x of h of g. Okay, you can write 1 minus of x h of f. Okay, plus x of h of g. Okay, like this also we can just write. That is our wish. Okay, so anyways, you write this one or this, you will get the same value. Okay, so what is mass? So mass doesn't vary. Okay, so what is the formula to get the mass? Okay, just think. So density equal to volume mass divided by volume. So volume equal to into density equal to mass. So total volume divided by specific volume equal to mass. Okay, so how we can calculate the specific volume? See, it's an easy question only, guys. Specific volume equal to, it means at the initial. Okay, mixture equal to specific volume of gas plus of x of specific volume of fluid in gas. Okay, so this x is at the initial condition 0.5. so calculate this one, mass equal to 1 meter cube divided by this one, put here. Now we'll get the thing. Okay, so while you are putting that, mass will come 10 kgs, 10.24 this kgs. Okay, just after that go and multiply 805.99 into 10.25 kgs. Okay, so later on you can see now kilojoule will come, but later on it means what we need to do, we need to just divide it by 10 hours. Okay, 10 can cancel, so 805.99 will be the accurate answer. Okay, 10.247 divided by 10 hours, so little bit of changing will be only 2.4. Okay, I think so I got the point. Okay, so we'll get the correct answer. Okay, that's it. Good question, just a basic sense is needed. Okay, that's it. So okay guys, then I will just see you in the next video. Until then, take care, bye bye, have a good day.